Mungu ibariki Tanzania, dumisha uhuru na umoja wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki watoto wa Tanzania.
Do you love the beauty of basic engineering and scientific mathematics? How are you, everybody who is watching this program? I'm very happy to have you, and I'd like to take this opportunity to welcome all our national and international viewers who are going to take advantage of these programs, who are really loving the beauty of basic engineering and scientific mathematics. Just would like to welcome everybody. Ordinary diploma students, you're warmly welcome. Ordinary secondary students, you're warmly welcome. Maybe VETA students, vocational training students, you're warmly welcome. So we are here, and I would like to join you in order to make sure that I transform your mindset from the present state to the new state. Okay? So my name is Olenjolai, Moko TAYAI Losingo. Simply just call me Olenjolai. I thank God by His own grace, He has called me in the field or in His calling of teaching the truths of engineering, mathematics, and scientific mathematics. And He has given me a coverage area, or it means that the area where I have to dominate in teaching basic engineering and scientific mathematics. It's a level, it's in the coverage of, of the training that the Lord has given me is the national, it means the Tanzania, the entire nations of the United Republic of Tanzania. And also in a large scale, it means that this contents is the global. So it means that I'm a global teacher by His own grace, and I'm also a national teacher, a Tanzanian national teacher. I'm a Tanzanian, and I'm doing this program specifically for ordinary diploma students who are doing engineering programs and science programs. So this is the national flag. If you are just a foreigner, you're only welcome into our country because we love foreigners so much. So that is what you have to expect. So what are we going to speak here? We are going to speak almost mathematical language with perspective or with a competence-based authority of engineering. So I'm very happy to meet you for the first time. You're warmly welcome. And then stay tuned. We'll be covering some stuff in 1 hour. And those stuff will make you to think differently and think outside of the bracket. So I would like to take this opportunity to welcome you into one of online institutions where we are mentoring and actually incubating ordinary diploma students who want to make a change in our present community. Okay, so online diploma. So we would like to welcome you into our online diploma Polytechnic Institute of Tanzania in square bracket Olenjolai, right? So in square bracket Olenjolai. Square bracket Olenjolai. Simultaneously, I'd like to welcome you into one of our official YouTube channel that's called Online Diploma Poly Institute of Tanzania in square bracket Olenjolai. Okay, that's the wonderful information. Whenever that you're being welcomed, so I know in your mind right now, if you meet me for the first time, you have never known me, you have never met me, you have never get assistance from me, you have so many questions. And that is even myself, I used to be whenever I meet new teachers, I meet new engineers, I meet new just politicians, new leaders. So I have so many questions. And if they welcome me into the year programs, I have so many questions. And actually, when I join into that program, so I get the answers of my questions from the just if day after day and session after session or programs after program. So let me just explain couples of the minutes to answer some of the questions, common questions that I know most students are used to ask themselves, or most viewers are used to ask themselves. The first question, what problems does Online Diploma Polytechnic Institute of Tanzania in square bracket Olenjolai solve? That's the question, right? That's the common questions. Are we solving a problem? Are we providing service? What are we doing? Yeah, so the answer is yes, we are solving a common problem, a common national and international problems. According to my research that I did it for almost 5 to 6 years, especially in my own country, I realized that many ordinary diploma students, they used to get challenges in learning and mastering modules or courses of engineering, mathematics, and scientific mathematics. I did my research at the Dar es Salaam Ministry of Technology. It was a kind of practical research. Many students, they used to have absconding, just the others, they used to end with discontinuous, and others used to have even retake and having so many supplementary exams for modules or courses of engineering and scientific mathematics. There are so many reasons that caused that situation, according to my research. I don't have enough time to share to you all of them, but one of the common problems or common cause of such kind is there is a great transition. There's a great shift, not even transition. There's a great shift between ordinary secondary education and ordinary diploma education. Most teachers in ordinary diploma educations, they used to assume that these students, they know some concepts about calculus. They know some concepts about differentiation, while in detail, according to the syllabus and curriculums of the United Republic of Tanzania, except for the students who have been studying additional mathematics. For the students who have been studying basic mathematics, they've never heard anything about calculus during the ordinary education. So that's one of the common causes. But the second common cause of that problem, actually we find that most teachers, they used to teach their courses in a zigzag style. But I don't want to talk too much about other teachers, but that's what I found, and it pained me a lot. And I took, for that institution, because I was an undergraduate student, then I took procedures to teach these ordinary diploma students during the weekend to half terms. And they gave me testimonies, they showed me their performance. Actually, their performance, they were just some, I think that 75% of students shifted from the F or from the C or D, from D, which is 24, no, not 24, yes, from the C grade to A grade. So the result were kind of drastically. Then I realized also it's not only the institution where I'm studying, even other surrounding institutions in engineering and science, they encounter the same problem. So that's why that I say that this the real life problems that I'm solving here, and I'll be solving by teaching all our students by using different teaching aids, teaching methodology. I'll be using different teaching techniques. I'll be using different styles of teaching, and I will be organized every teaching or every session that I'm going to teach you. So you have to stay tuned, but I will give you another advantage. I will give every student an opportunity to ask me questions by using the comment section. Later on, so you have to keep on praying. I'm trying to develop a system which actually I can interact with my students, and even we can speak my students can write the mathematical expressions in that program, so they can send me the work that they do mathematics. Because in comment sections, you just have to write the text. You cannot write, maybe for example, okay, just the integral, maybe integral of sine of x. You cannot write there in comment section, so I know that. But soon I will inform you about another interactive platforms which we can interact in more and speak the mathematical language and scientific language or engineering language, right? Then another common question is, what vision do we have? Yeah, because according to the book of Proverbs, 19, verse 18, it states that where there is no vision, people perish. So we have vision. We are going somewhere. We have destiny, destination, and we have a legacy that we want to live. And this is an assignment that we've been given by God Himself to teach ordinary diploma students on how they can extract knowledge, understanding, and wisdom from the classroom instructions, combine it with knowledge, understanding, and wisdom that we are going to teach them to extract it from the Word of God written in the Holy Bible, in order to solve real life problems. So our vision is clearly defined in 4 parts: extracting knowledge, understanding from the classroom instructions in fundamental and core courses or programs. Then combining it. Combination means combining with an extract of knowledge, understanding, and wisdom that we extracted from the Word of God. And then the 4th part is using the combinations to solve real life problems. That's all. Okay? It's not simple the way that you think. Myself, I'm a product of this vision in my own life. I used to enjoy applications or combinations of knowledge from the classroom instruction that I learned, and with the knowledge that I learned from the Word of God, and I will keep enjoying for the rest of my life. So right now, I'm taking another step also to make sure that I incubate others to have even success, to have success more than I do, because as good an excellent student always has to succeed more than his or her own teacher. All right. So remember, the main objective of ODPITO means ODPITO is abbreviations of Online Diploma Polytechnic Institute of Tanzania, in square bracket Olenjolai, is to train our students how you have to think outside of the classroom instruction and think how you can apply the knowledge that you've been accommodating or you've been gathering to solve real life problems. Well, so before we start today's sessions, which is actually lecture 2, let me just speak within a couple of the minutes about some few steps for you to register in ODPITO. How can you register in ODPITO? ODPITO is abbreviations of Online Diploma Polytechnic Institute of Tanzania, in square bracket Olenjolai. So these are the few steps that you have to follow to register yourself permanently, and also registrations and access. So it means that the registrations is just from number 1 to number 4. Then number 5 to number 7 is just how you can access our contents. Where can you find what you're looking for? Okay. The first step, if you don't have an email, create or open a new email. It can be a Gmail or a Yahoo Mail, right? This is kindly engineering. I'm electrical and electronics telecommunication engineering. I'm electronics and telecommunication engineering, that is formally, but informally, I'm electrical engineer and computer statistics. So what am I going to teach you, I apply. But remember that Olenjolai does not know everything about basic engineering mathematics and the basic scientific mathematics. I know a small portion, but I have an assignment to teach others what I know, right? I'm always learning different concepts of basic engineering and scientific mathematics. So the second step, once you have your email or you have an old email, remember your password and username, then sign in YouTube by using your email. You cannot sign in without email. That's why the first step, you have to create or open a new email or retrieve your previous email. Then the second step, we ask you that search ODPITO in your in YouTube, right? ODPITO. Don't write ODPITO. Just write this name: Online Diploma Polyinstitute of Tanzania, in square bracket Olenjolai, right? So great. So if that's the case, we say that once you search, if you click the buttons of search, you'll see a round button like this, which has a Tanzania flag. Beside it, you'll see the names Online Diploma Polyinstitute, of 40, Polyinstitute, okay? Polyinstitute of 40, Polyinstitute of Tanzania, square bracket Olenjolai. You'll see the number of subscribers. You'll see horizontal title: Home, Videos, Playlist, Channel, Community, About. So once you are there, you are nearby. You have found our online poster. This is kind of like you see the poster directing you where the school is, right? So now, to arrive to the real online schools, click this button. Once you click, then you are inside, and you'll find that we welcome all our students. I and my students, we welcome you. Welcome our dear guest, welcome our dear student, welcome our friends, welcome to enjoy, right? And then when you are there now, so then we ask you now, we can share with you how you can register yourself so that you can be a permanent students of ODPITO. So we ask you that to click. You'll see on the right hand side, at the bottom of the right hand side, you'll see the buttons which has been written subscribe. Click. Once you click it once, you change into subscribing. Then an icon of bell will appear. Then click the icon of bell only one. Then you see 3 options. Choose options of all. After that, you have already registered yourself permanently, free of charge. You have already registered yourself in our online institution, right? In our Online Diploma Polytechnic Institute of 40 of Tanzania. That is. So then the fifth step, how can you access our contents? We have a vision to record more than 300 videos about basic engineering and scientific mathematics. But that's not enough. We also would like to teach you about the kingdom of heaven. So we have another department that we call kingdom of heaven. We'll teach you how to praise God. We'll teach you how to worship God. So you have some departments, just like in any other schools, there are departments. So currently in our online institutions, online diploma Polytechnic Institute of Tanzania, we have 4 departments. This is one of the departments that called basic engineering and scientific mathematics. But you have other 3 departments, which actually will teach you how you can extract knowledge, wisdom, and understanding from the Word of God. Wonderful. Okay, so it means that click the playlist. When you click the playlist, we organize our contents in form of the subject. So we create a playlist for the subject, we create a playlist for the module, we create a playlist for the subject or module or course, we create the playlist for each chapter. So each chapter or each topic, we create this playlist. For example, here we are dealing this is first topic is called numerical methods. So when you click the playlist, search the playlist which are titled as what? Numerical methods, you will find the collections of all the lectures about numerical from the first lecture to the last lecture. That's the wonderful thing, because it will redeem your time on hustling, on searching lecture 2, where in the next lecture, lecture 3, so you can spend much time and you can even using trial and error method, which is not effectively. Then the 6th is say you can click also channel to see our other channel. For example, we have some other YouTube channel, some other 5 YouTube channels, and one of them is online Undergraduate Polytechnic Institute of Tanzania square bracket Olenjolai. This will help you when you'll be in the next level of education, which is undergraduate or bachelor degree in engineering and science. You will find that this another online institution is benefit for you or is important for you. But also we have for your young brothers, for example, we have to also just click there, you'll see. Number 7, then I know that you'll find our contents are important and are actually are making radical change in your mindset. So you like to share how you can share with other students. You can share with any students across the country of Tanzania and even internationally by clicking the icons which is you can share to OT2, and then so you'll be given the video link, and you can share this through any social media, right? All social media, Facebook. You can share this content through Facebook, through WhatsApp, the video. You can share the video link through TAYAI. You can share the video link through email, through Twitter, through Telegram, through Instagram, through TikTok. So you have different ways. I can say that 10th ways of sharing this content. Wonderful. So I believe that you are well informed and you are no longer, in case of the information, we know that you are good in information. You have more information more than we think. Okay, our dear engineer, our dear scientist, let us go into the lecture 2. What are we learning? We have we are in departments of basic engineering and scientific mathematics. Module or course is called numerical method and series. Numerical methods and the series is called the numerical method and series. Then we are, this contents is for the 3rd year ordinary diploma NK level 6, right? And then this is chapter 1, which is called your numerical methods. We are in lecture 2, which is derivation. We'll be focusing on derivations of Newton-Raphson formula. We'll be defining what the means of Newton-Raphson formula. That's all. So again, in case you feel from your hearts, right now at the beginnings of this lecture 2, or in the middle of the lecture 2, or at the end of lecture 2, that you feel from your hearts you want to offer our God, our sovereign God, through these programs. You are freely thanksgiving, you are seed offering, you want and you have to offer it with a heart of generosity, right? So you can achieve that goal by offering through the telephone number 0759745331, and you may offer free will thanksgiving of an amount to be received and to be used to pay for the running costs, so that more than 300 videos of basic mathematics, more than 500 videos will make them. So, and we'll make them free, right? It's very expensive, more than we think, but God is a sponsor and founder of this program. So let us go into the class. So, quick review, okay? Get prepared to enjoy. Quick review. Quick review of lecture 1. So the previous lecture, before the lecture 2, is lecture 1. So in lecture 1, if you do remember what we have covered, firstly, we defined what is numerical method. So we defined some terminology, numerical method. What is numerical method? Okay? And then we define about what is what? What is numerical method in what? In engineering. What is numerical method in engineering? Right? And then another question that we have, or another concept that we have been covering, or we have covered about numerical method. We've also introduced it to you about what? Numerical method, numerical analysis. What is numerical analysis? Okay, numerical analysis. Then afterwards, after teaching numerical analysis, we've taught you about we've taught you also about numerical methods involve linear interpolation. Taught you about what is linear interpolation. Linear interpolation. We taught you about iterative. These are the sum of the numerical methods that we have to cover. Okay, iterative methods. Then we have what? Numerical integration. Numerical integration. And then we have error analysis. That's what we have introduced it to you. Then another terminology that we have focused on is what is linear interpolation. What is iterative method? So we have focused also on iterative method. So we taught you what is iterative method. What's iterative method? Okay? What's iterative methods? And then we mentioned the 4 iterative methods where we say that. So 4 iterative methods. The first one we say dissection. Second one we saw what? Regular fuzz. Okay, the third one is called what? Okay, so bisection, regular fuzz. The other one is called the second method, and the other one is called Newton-Raphson method, which we are focusing today. So simply we define numerical method. A numerical method is a mathematical tool designed to solve numerical problems, or is a study of approximation techniques for solving mathematical problems, taking into account the extent of possible errors. Right? So we've been just presented. Then I left the homework, and let me start from there. So today we are focusing on what? So let me start with correction of 40. Correction of homework. I left you the homework. Correction of the first homework, which is homework 1. And the question was asking you that what is. So the question asks you what is iteration? What is iteration? Now the question that I left it to you. Did you do it? Let me know in the comment section if you've done it. Okay, so let us focus, or let us answer this question. So what is iteration? Ladies and gentlemen, the word iteration, this is very important word in numerical method and also computer science. So iteration, I found 2 definitions, no, 1 definition. Iteration is a repeatedly, okay, so he said that is a repeatedly application. It's a repeated application of what? Of a function, or what? Or process. It's a repeated application of a function. The application of a function or process in which the output of each step is used as input, is used as input for the next iteration. see this in the next in the lecture 3. So this is formal definitions of iteration. Say with me, iteration. Say again, iteration. Say it, iteration. Iteration in numerical methods or in mathematics or in engineering mathematics and also computer science, this is the repeated application. So we'll be repeating. Very interesting. Okay. This is the repeated application of what? Of a function or process in which the output of each step is used as input of what? For the next iteration. What does it mean? Listen carefully. For example, we've been given a certain function, f of xn, maybe is equal to x squared plus 4x minus 3. It's a quadratic function. Right? So for the first iteration, listen carefully. For the first iteration, but we've been given initial value when n is equal to 0. This is equal to 2, for instance. Right? So for the first iteration, we say that we have to find f of x naught, which this one is equal to f of what? 2. When we find f of 2, we'll get a certain response. Right? We'll get a certain response. So this response are the response of f of 2, which will be the response, means that the value of y, when you substitute x is equal to 2, will be the input. So that ones will be becoming what? The next what? Will be becoming the initial value of x. Okay? Will becoming the initial value of what? Of x. For example, that you substitute x is equal to 2, whatever, means that, okay? Yeah. Will becoming what? The initial value of what? Of x. That suppose that we've been so finding the roots. Okay? So find the roots just like that ones for that case. So for example, x1 here, we got that is 2.42. So this one becoming the input for what? For the second iteration. So for instance, the second iteration, we can find the second iteration for f of x n plus 1. Right? So which this one is equal to f of x1. I know that for many students, they may not understand it well, but you will understand because I remind you that this is what the meanings of iteration. I want just to give you the big picture. So the second iteration will be that when f of x n plus what? Plus 2. And then this one, remember this is f of x1. So this will be f of x2. So it means that if you are finding the roots, when the roots are near to 2, okay, the first root is x is equal to 2.4. The second root, which will use the same function, which is x2, but we use the different value of initial value. Here it was 2, here it is 2.42. Then you can find this what is 2.23. So this output will be used as the initial output for the next iteration, which is the third iteration. So this one will be fed here to find the value. So we do that until we find the values of the consecutive iterations is nearly the same. That the means of 40 of iteration. So that's why that we define the word iteration as is the repeated applications of the function or process in which the outputs of each step is used as input for the next iteration. And I want to tell you that, my dear student, this is what makes computers to do computations, because the computers use the concept that we call guess. Okay? So you have the initial guess, and that's what we call the algorithm. Okay? In searching, for example, that searching, if you're writing the data structure of search, then you'll find for this the situation that I'm telling you. Okay? Another piece of information to share with you about iteration is this is very important terminology. So iteration is an important tool. It is an important tool. Iteration is an important tool for solving what? For solving problems. For solving problems. And then we say that example, Newton's method. Newton-Raphson method, which we are going to learn today. Method. So this is the method that uses the concept of iteration to solve problems. as well as a subject of investigation. So iteration is an important tool for solving problems as well as method of 40 as well as a subject of 40 of investigation. Subject of 40 of investigation. So that is a 40. That's all about 30, the word iteration. So it's an important tool for solving problems, example Newton-Raphson method, as well as a subject of 40 of investigation. Okay, so that's all about 30, about the iteration. So let us focus on today's concept. As I say that the basic concept we are going to learn about 30, about the beauty of 40 Raphson method, Newton-Raphson method. So, ladies and gentlemen, write this subtitle and then get prepared to receive good news. So today, another concept after learning the concepts of iteration, we are going to teach about Newton-Raphson method. Newton-Raphson method. And this, in abbreviation, we call it NR method. Okay. This is the fundamental question. What is, for the today's session, this question number 2. What is the meaning of 40? What the meaning of the word Newton-Raphson method in basic engineering mathematics? What does it mean? So I have formed 2 definitions which I'm going to share with you. And the first one is this one. In numerical analysis, Newton-Raphson method, or in other references, it's just called Newton method, named after, so this method has been named after what? After Sir Isaac Newton and Joseph Raphson. So these are the names of the 2 great mathematicians. Joseph Raphson is, so this Newton-Raphson method is a root, so this is a root finding, algorithm, okay, algorithm which produces successful better approximation, better approximations to the roots, better approximation to the to the roots or zeros of a real value of a real valued function. A real valued function. That is the first definition of Newton-Raphson method. So let me give you a minute to copy the definition, then I'll explain before I give you alternative way or alternative definition of Newton-Raphson method. So today, in case you will forget everything that I'm going to teach you, but bear in mind that today Sir Olenjolai taught me about the Newton-Raphson method. That is a good fundamental concept to keep in your mind in this world of today. As technicians, there is something we call it the Newton-Raphson method, right? And these are the names of the two mathematicians, and they were mathematicians like you, they were human beings like you, and they did great contributions in mathematics, and their names have been given, and they have been given in the numerical method, Newton-Raphson method. So what do you think about it? Maybe later on, just to do your mathematics, you investigate different issues and you come up with your own method, and then you say John Ramadani's method. Yeah, it's possible. What is the meaning of Newton-Raphson method? In numerical analysis, we say the Newton-Raphson method or Newton's method, named after Sir Isaac Newton's and Joseph Raphson. Okay, Joseph Raphson. Let me check the spelling for the Raphson. Yeah, everything is correct. Joseph Raphson. So these are the founders of this method. Sir Isaac Newton. Okay, they published a paper, which even yourself in this age you can publish. So simply is a root finding algorithm. Algorithm means it's a step-to-step process of performing a certain action, which produces successful beta. So this one produces successful beta approximation to the root or zeros of a real valued function. So the Newton-Raphson method is limited to the real valued function, right? It won't deal with a real valued complex, or it won't be focusing on a complex valued function. So what the Newton-Raphson method that we are going to start today, root finding algorithm, which produces successful beta approximation to a function, okay, or to the roots of a real valued function. That's the meaning of Newton-Raphson method. Okay? Can you think how you can define alternatively? Pause the video and then try on the piece of paper. Write your maybe advanced secondary education definition if you come from A level. So the second way of defining the Newton-Raphson method, so is this one. So say the Newton-Raphson method. Newton-Raphson method or Newton methods or Newton method, okay, is a powerful so this is a powerful technique for solving equations. equations numerically. So Newton-Raphson method or Newton's method, okay? Newton's method is a powerful technique for solving equations numerically. Okay? Numerically. Like so much of the differential calculus, it is based on the simple. So Newton-Raphson method based on what? Based on simple idea of linear approximation. Linearity approximation. So based on the simple idea of linear approximation. So Newton-Raphson method based on what? Based on simple idea of linear approximation. So we're dealing with linear approximation. Okay, like what? Like differential calculus. That's the concept that you have to remember. So, ladies and gentlemen, before we derive the formula of Newton-Raphson method, then let me teach you about what conditions necessary for Newton-Raphson method. So conditions necessary for Newton-Raphson method. So conditions necessary for the Newton-Raphson method. So he said that for the Newton's method to give what? For the Newton method to give the most accurate result, the most accurate results compared to other three iterative methods. We mean what? Second, regular phase, then what? Second, regular phase, bisection. Then the problem, then the given problem has to obey the following conditions. So the given problems has to obey the following conditions. What are those conditions? The first condition, we say that the function, the given function that you have to estimate or to find its approximation, the given function must be differentiable. Say with me, differentiable. Differentiable. So the given function must be what? Differentiable. Given function must be differentiable in the given interval in the given interval close to the initial guess or initial value, which in this case we use this notation x naught. So the first condition for the Newton-Raphson method to give us the best iterations with few to give us the most accurate result with fewer iteration compared to other 3 iterative methods. Then the first condition is the given function must be differentiable in the given interval close to the initial value, or initial guess. That's the first condition. Ladies and gentlemen, can you give me the second condition? The second condition, the initial value or the initial guess must be given in the question. So you'll be using as the input for the first iteration. Then the output of the first iterations will be used as the input of the second iteration. Then output of the second iteration will be used as the input of the third iteration. Then the outputs of the third iteration will be used as the input of the fourth iteration. Then the outputs of the fourth iteration will be used as the input of the fifth iterations. So you go continuously until you get the best approximate. And that's the best, or that's the responsibility of the engineers to design systems that solve real-life problems, to design systems that simplify lives, right? To solve problems. So the second condition is where the initial value should be given for the first iteration of Newton-Raphson method. So the initial value of what? Let's say of independent variable, which we call it mostly x, must be given for the first iteration. For the first iteration of what? Of Newton-Raphson method. So the initial value of independent variable x must be given for the first iteration of Newton-Raphson method at the initial value, right? So must be given. Okay, so ladies and gentlemen, those are the conditions, that the meanings of Newton-Raphson method. These are the definitions of Newton-Raphson method, 2 definitions. And this is just the actual method. We say that the Newton-Raphson are based on not on the simple idea of linear approximation. This is all about linear approximation, like differential calculus. And then these are the 2 conditions that have to be obeyed by the functions in order for the Newton-Raphson method to give you the best approximate by using fewer iterations compared to other iterative methods. Do you enjoy it? Do you understand what am I teaching you? Please tell me in the comment section. Give me feedback in the comment section, please. Say something there. Give me the feedback in case you have any question about definitions of Newton-Raphson method, about the base of the Newton-Raphson method, and then about the 2 conditions of Newton-Raphson method. Ask me in the comment section, please, there. I used to visit that place to see questions asked by my students, because this is interactive program. And the heart of online undergraduate, online diploma Polytechnic Institute of Tanzania, square bracket Olenjolai, is understanding. Understanding is the heart of our program, right? It's the heart of our program. Then accepting or listening questions from our students, it's the fundament, it's the foundation of auditor, right? So ask your questions as well as you can concerning about the idea that we've learned today. Okay, so let me take you into the second part of this lecture 2. The second part now, it's a part that we are going to speak more mathematical language, which it is derivation of Newton-Raphson formula. Derivations of Newton-Raphson formula. That's what we are going to focus right now. So ladies and gentlemen, let me introduce to you the subtitle of derivation of what? Of Newton-Raphson formula. Remember that NR, remember that not in maths, whenever you see NR, this stands for Newton, N stands for Newton, R stands for Raphson. So it's an abbreviation that you're using in most cases. Okay, so we say that to derive the formula of of Newton-Raphson for Newton-Raphson method, then follow these steps. Follow these steps. The first step so consider the graph of what? Consider the graph of a differentiable function f of x. Okay, f of x with its what? Its tangent line. With its tangent line. So let me draw the graph here. It's a kind of a trig graph. So you have to try your level best. Because when you say tangent line, it's a straight line that touches the curve at only one point. But when we're sketching this graph, you'll see that that's one point we used to extend it. Okay? So let us draw it here. This is what? Y-axis. This is what? X-axis. No, still Y-axis. Huh? Listen careful. My dear students, stop writing. Stop writing. Listen careful. Listen about this graph, because it's a fundamental concept of this derivation. If you understand this graph and how you locate the points, and then the derivations will be simple. So listen and then follow along. Stop writing, stop drawing, listen and watch. Watch and listen. This is the x-axis. So now we say that suppose we have a certain graph, that cutting the x-axis. So this is the graph of our function f of x, right? Yes, there are functions of f of x. Then we have a tangent line. And this tangent line just touches 2 points. We know the tangent lines, for example, if it touches this point, then it touches that point. But for this case, we'll just see like extending this, magnifying this point. For example, if you have this point, if you do magnification, this point, if you do magnification, you can see this point as a line. So let us consider that the tangent point to be, it is being magnified. So it just magnified in a lens to have a line. But actually, it's a point, right? Bear that in our mind. Because I know that we taught you tangent line in calculus. So this is the tangent line. It's a line that touches only 1 point. Okay, it's a line that touches only 1 point. So this is the straight line. So this is tangent line. So this is the tangent line. And you know the tangent line, it is y is equal to mx plus c. So here you have 2 values. You have 2 points. You have this point, and in this point, so this one, we say that here we have the x coordinates is not 0. It is x n plus 1, comma 0. We obtain, remember that, for example, if you've been given x squared plus 4x minus 2 is equal to 0. What does it mean? It means that the value of y for this case is equal to x squared plus 4x minus 2 is equal to 0. So y is equal to 0 in order for you to find the roots of quadratic function x squared plus 4x minus 2. So that's why that this will be the point where we'll be using to find out the roots, or finding the best approximate, because at this point y is equal to 0. Let me repeat. Always we used to, since our form to education, we can solve the equation like this one. But you've never thought that what the means of 0. So the equation is equal to 0. It means that the equation is x squared plus 4x minus 2 is equal to 0. It is true. But also y is equal to x squared plus 4x minus 2 is equal to 0. So y is equal to 0. So the root of this function, we can get it when the value of y is 0. So here, this is the point, this we call it the x-intercept, right? So this is the x-intercept. So the x-intercept is the one that's going to give us what? The best approximate. Then here we have again another point of intersection. Remember that this is the point. This is the point of tangents, or tangent point, but we have magnified it. So here we do have also another point, and this point now will be having again another point here. Okay? So to avoid confusion, so this point of x-intercept, it is here xn plus 1, comma 0, this one. While here we have also another point. And this point, it is what? What is xn, and here we have what? f of xn. So here we have xn, come out. Yes, xn is out, because this is just like prolonged. Alright? So it means that, just to draw it clearly, suppose that this is the tangent line. Listen carefully. Then here we have what? A tangent line like this. So this is where the x-axis cut. So the coordinates at this point is what you call the xn plus 1, comma 0, because some other students ahead, the Holy Spirit telling me that some other students, they didn't understand this one. And then here we have another point. So we have a dotted. So this one will be corresponding to what? Xn. So because corresponding to Xn, it's the value of y, it will be f of x, what? Now. Right? So for that case, this point, so suppose that this is point A, this is point B, and this is point C. So point C for this case, it is what? Xn, comma what? F of Xn. Okay? So it means that if this point is, it's the coordinates of these points are x of n plus 1, comma 0, then the coordinates of this point will be what? Will be xn, comma f of xn. Right? Those points are very important, my dear students. You have to make sure that you understand it. So this is what? Figure. Figure 2.21. So remember that this is not part of the graph. It's not part of the graph. Just this is clarification. More clarification for those who didn't understand what you have there. So it's not important for you to do it. The graph is what I've drew there. But that is just like a magnification. Are we together? Okay. So for that case, for instance, I mean that I can draw a line like this one, this way, for you to understand. Here you have point C, which is coordinates are xn, comma, f of xn. And here again we have what? Xn plus 1, which will give us the best approximate commodity, comma 0, which is x-intercept. Alright? So this we call it point what? So this is point A. Okay? So this is the straight line right now. But you say it is a point, but you can magnify it to become what? A line segment like this. Okay? So that's for the first step. So this is the second step for you to understand. So after this second step, we have that. Then we have to focus on what? On the second step. Second step. So second step, we say what? We call what? We call the concept of what? Of gradient. Gradient of the line. So it means that the slope, which is m, is equal to change in y over change in x. Okay? So simply say that slope of the line, what is change in y? So change in y, let us take the coordinates of A minus coordinates of C. So coordinates of A, we have what? Set that because you have to be careful. Now let us take coordinates of what? Of C minus coordinates of A. So coordinate of C, the y coordinates of C, it is what? F of xn minus what? So f of xn minus 0 divided by, for the x coordinate, you have xn minus xn plus 1. If you join me, you're warmly welcome. I'm deriving the general formula of Newton-Raphson method or formula. So that is a gradient. So it means that the gradient of that straight line, the point at the point of the tangents, so will be equal to f of xn divided by what? Xn minus xn plus 1. And this is equation 1. I know that many students, they used to claim the general formula of Newton-Raphson formula or Newton-Raphson method. And that is appropriate way of writing of learning. Why should you create? You have to know where should you start in your derivation, that's all. You have so many formulas in basic engineering and statistical mathematics. So if you want to cram, then you get some stuff. You get surprised that you cram, and while you're cramming this, and the other steps are quitting from your mind. First step. The first step we have now the gradient. You have to go back into calculus, right? Into calculus. So we say that recall recall concepts of concepts of calculus. Which concepts of calculus you have to recall? We say that slope, which is equal to gradient, which you use m, that this is actually is equal to it. This is equal to first, is equal to derivative, right? The 40. So we call concepts of calculus. So slope, gradient is equal to slope is equal to what? Derivative of the function. Derivative of 40 of the function. So also from the derivatives of the function, so we say that slope is equal to f of x and dash. That is so this is the derivative of 40, derivative of the function, that means of f dash. It's one of the notations of differential or of calculus. Okay, so the slope m. So it means that right now the slope with respect to calculus is m. This is equal to f dash of x m. So ladies and gentlemen, suppose that this is question 2. Then we go for the fifth step. Fifth step, we say that substitute question 2 into 1. Into 1. So we have what? So we'll have f dash of what? Xn, which is equal to what? Is equal to the function of xn divided by what? Xn minus xn plus 1. Okay? So this is derivative of the function f of xn. Because it's gradient. Why is it derivative? Because the gradient, it is changing y over changing x. So n derivatives depends on the changing on dependent variable with respect to what independent variable. Okay, so if that's the case, you say that we go for the sixth step. So you substitute there, go for the sixth step. Sixth step, we say that make now what? So make xn, means that the next iteration came a formula. Xn what? The subject. So this is equation what? This is equation 3. So make xn subscript of 1, the subject. In what? In equation 3 above. Okay? So let me leave this graph for you to keep it in your mind. I might be done some errors on sketching quickly, but you have to sketch it correctly as well as possible, because we'll be sketching with with drawing tools. So it means that here we have f of xn dash is equal to f of xn over what? Over xn minus xn as well. So if that's the case, we have 1 here, you have to cross multiplication. So once you cross multiplication, you have f dash of xn Okay, f dash of xn, then this is xn, that's xn plus 1. And this is equal to it, 1 times f of xn. Okay, so if that the case, so mean that we have f dash of xn, and then we have what? So you can have even normal bracket, xn minus xn plus 1, right? This is equal to what? f of xn. So we're making it the subject. So you have to divide by what? f of xn dash to both sides. Divide here f of xn dash. Then if that's the case, you have what? xn minus xn plus 1. This is equal to what? f of xn over f dash of what? xn. Okay, so to make this a subject, you have to bring this on this side and bring this on this side. So it means that xn minus what? f of xn divided by what? Divided by f dash of xn. This is equal to what? xn plus 1. We have made xn plus 1 the subject. What you see there is what you call the general formula of Newton-Raphson method. Wonderful. This is what you'll be looking for. It's not difficult. You have just to practice. Watch this video several times as you can until the revisions of Newton-Raphson method is kept in your mind, because it can be asked at any time. It's one of the common questions. Great. So for that case, you say that here we have xn plus 1 is equal to what? Is equal to xn minus what? Minus f of xn over f dash of xn. So ladies and gentlemen, this is general formula of Newton-Raphson method. Okay? So the general formula of Newton-Raphson method is xn plus 1. We'll be using this formula. Okay, is equal to xn minus what? f of xn divided by f dash of 40 xn. Like that. Okay? So that's the concept that you have to remember. Okay, so this is the general formula. We have the general formula. Then what does this general formula tell us? So let me define some of these terms. So we have some vocabularies there. So we say with that general formula, say where n, this is representing what? Number of iteration. We've got notations of, yes, notations of, or notations of gates, or notations of what? Of iteration, let's say. So n stands for counter. It's a counter of iteration. Counter of iteration. And the value of n always starts from 0, 1, 2, 3, 4, 5. If you have 5, if you have 6 iteration. So 0, this is representing what? First iteration, second iteration, n is equal to 2, that is third iteration, n is equal to 3, that is fourth iteration, n is equal to 4, that is 5th iteration, n is equal to 5, that is 6th iteration. Alright? So that is how we label the iteration. Okay? So if that's the case now, because the new term here which is common. Here we have n, here we have n, here we have n, here we have n. So n, it's a cross-cutting. Okay, and so I think that you've been zooming and just the diagnosis or digesting this graph. So now, just to clarify or to open your eyes about what we're expecting. So for that case, for example, so we say that, for example, the first iteration. So the first iteration of what? Of Newton-Raphson method, will be having these values. The variables, so it means that first of all, the value of n is equal to 0. If that's the case, then we have what? So we have what? We are going to have x of 0 here because n is 0. N is 0, so this one will be x of 40 of 0. Then for this one, it will be what? x1, the other one, which will be finding here because 0 plus 1. Then we have again another function, f of xn. So this one will be f of x0 because n is equal to 0. And then so we have what? The first derivative f dash of x naught because here we have also n. That the first 30 iterations of Newton-Raphson method. For the second iteration, so I want you to understand, tell your neighbor understanding is coming. For the second iteration of 40 of Newton-Raphson method, first of all, the value of n is 1. Secondly, the value of the first value, means that the subscript of xn will be equal to x1. The subscript of xn plus 1 will be 1 plus 1, so the subscript will be x2. Then we have what? The numerator function. The numerator function will be f of 40 of x n, subscript of n, but the value of n is 1. And then the denominator, this one, is f dash of 40 of x subscript of 40 of 1. That is for the second iteration. For the third iteration, this might be, I know it's a new concept for many students, but you can get confused if you won't be careful. So that's why we are building this foundation in your mind so you'll be accurate student. Won't do just a mistake easily. So for the third iteration of Newton-Raphson method, n will be 3, regardless of which maybe we are finding the roots of the function, maybe we are finding the reciprocal of a number, maybe we are finding the nth root of the number. So regardless of what method or what kind of applications or where you're going to apply the Newton-Raphson method to solve problems numerically, the concept you have to bear in your mind is actually, you have to remember that the iterations will be employed effectively. So here we say that the value of n is equal to 2. Okay, so because it's equal to 2, the subscript of xn will be x2. The subscript of xn plus 1 will be what? x3. Then the numerator function, which is f of xn, will be f of x2. Then the numerator function, this will be f dash of what? Of x2. That is. So in most cases, we end with third iteration, in most cases, because the Newton-Raphson method uses few iterations to give us the best approximate. But you can maybe, okay, so just this is the quiz. If you've understood now, write the values of 40 of n itself and its subscripts values. The first iteration of what? Of Newton-Raphson method. So try to fill the blanks. That n will be equal to what? Then n will be equal to what? Then the next is this one. Okay? And then the next one, the corresponding x n plus 1. then this one, BFFX what, then this one, F dash of what. So this is just a style. You see, so I began by giving the general picture, and then I've been speaking too much, and then you thought that we won't speak mathematical language. Right now we are speaking mathematical language, and then you have noticed in your mind, because I heard in my spirit that you are saying that, and you are preaching yourself, mathematics always is a difficulty. It's difficult. No, it's not difficult, because of these kinds of FFX and whatever. Okay, so this is what we say that it is general concepts of mathematics. So this is the beauty of engineering mathematics. So fill the blanks as how we've done it in those other aspects. Okay, so after that, so we say that we have the previous. So remember that another point to note, not before, xn, this representing what? Representing previous iteration, previous or initial iteration. Okay, initial iteration, right? Then we have what? Xn plus 1. This representing what? Next iteration. Okay, next iteration. So this next iteration, this previous or initial iteration. So you have to understand. Next iteration, previous iteration. You have to remember that. And that's the derivatives of original functions, and that is okay. So before I end this session and I give you a kind of challenging, just a simple challenge. Ladies and gentlemen, let me teach you about applications. Applications of what? Applications of Newton-Raphson method. Newton-Raphson method. Applications of what? Of Newton-Raphson method. Okay, so in numerical analysis, there are three applications of Newton-Raphson method. Okay, pause the video and mention them. Can you try to mention them? Pause the video and mention them. So in numerical analysis, there are three applications of Newton-Raphson method. Okay, these are the first one, approximating So we use Newton-Raphson method to approximating or estimating, in other way, approximating or estimating the root of the function. The root of the function. So we use the Newton-Raphson method to approximate or estimate the root of the function. In most cases, it can be a quadratic function, can be cubic function, can be cubic functions, and then the fourth one we call it's a function is the highest degree of 4. It can be also a function is the highest degree of 5. It depends, but in most cases is quadratic function, cubic function. That's the first application. The second application, we use Newton-Raphson method also to estimate it, to approximate the reciprocal of a number. To approximate the reciprocal of of a number. Reciprocal of a number. Then you have number 3. Also, Newton-Raphson method is used to approximate the nth root of what? Of a number. The nth root of a number. So these are 3 applications of Newton-Raphson method that you have to cover according to the syllabus. The first one, it's used Newton-Raphson method in engineering and science to approximate or estimate the root of the function, because you generate functions in solving engineering problems, and also to approximate what is the reciprocal of a number. For example, that you want to find the reciprocal of a number, we don't use a scientific calculator, we use the Newton-Raphson method, which is the best to approximate. Then the third one is to approximate the nth root of 40 of a number. To approximate the nth root of 40 of a number. Okay? So to approximate the nth root of 40 of a number. So that's another concept that I wanted to share with you in order to excite your mindset. So let me try to leave the question homework for you from the past paper. Okay, try to solve this homework. If you've understood the Newton-Raphson method, then try to do this homework. You might just try. If you fail to get the right answer, don't worry, because we'll do the correction in lecture 3. Okay? So this is example 1 for the numerical question. We say that you should have past papers and use them as a reference material. So refer DIT final exam or end of semester exam of 2017, question 1, Roman 3. I want to show you the real picture of numerical method and series. So starting with x naught is equal to 3, find a root. Find a root of 40 of x cubic minus 3x minus 5 is equal to 0. Correcting to 4 decimal places. Correct to 4 decimal places. The condition used Newton-Raphson to perform 3 iterations. If you succeed to do that, you will be awarded 4 marks in that exam. The questions is too simple. Starting with x naught is equal to 3, that is initial one or initial days. Find a root of 40 of this cubic function, x cubic minus 3x minus 5 is equal to 0. Correct it to 4 decimal places. Use Newton-Raphson, so delete. Use Newton-Raphson method, okay? Use Newton-Raphson method, use Newton-Raphson method to perform 3 iterations. Perform 3 iterations, then this is the full stop. So it's simple because this is an example of the first application. The good news, I'm going to teach you, the next lecture, which will be lecture 3, I'll teach about applications and estimations of the roots of the function. And then the lecture 3, I'll teach you about to approximate the reciprocal of a number. The lecture 3 is this one, this is lecture 4, lecture 5. So in 5 lectures, I will cover all about 30, in 4 lectures about Newton-Raphson method. And maybe at the lecture 6, maybe we can solve various problems of Newton-Raphson method. So a very simple question, if you've understood what I've been teaching you, if you forget, if you find the questions difficult, okay, those are the challenges even myself encountered when I was learning this concept for the first time. But I ask you to watch this video and learn these contents and repeat to watch this video several times as well as you can, so that you may get understanding and knowledge and wisdom and apply it for the rest of your life, right? So make sure that you do that and you do this homework and you give me the feedback on the comment section, because you cannot show me that how you did. But later on, we'll have interactive platform where you can do your work and take a photo of it, use a cam scanner, and then send to me. Then I can just give you the feedback and correcting the mistakes that you've done. But I want to teach you in such a way that you can correct yourself. That's the main objective. That we want to teach our students to be self-centered students, self-centered technicians, self-centered competence-based technicians. That is our focus. That you do the question, if you do wrongly, you discover, it means you identify yourself, you notice that you are wrong. If you do it correctly, then you clap the hands for yourself. And myself as your teacher, I like to congratulate my students who get the right or who solve the questions correctly. And I would like also to congratulate students who just didn't get the right answer, but they worked hard on the given problems in different styles, and they did just minor mistakes, because it's very simple for me to correct those mistakes, right? Stay tuned. That I gave at the beginnings of these sessions, I gave you a promise that say with me, right? I have a good news, and it's the good news that God has put in me. I thank God who have created me in His own image and likeness, and I thank God who have given me a gift of teaching. I thank God who have given me a gift of engineering, okay, in electrical engineering. I thank God also who have given me a national teacher who is teaching all the diploma students, and I thank God who have given me wisdom on how to teach His people of present and future generation. This is the end of lecture 2. Before you quit, or before we end the sessions or end the class of today, I would like to tell you again, in case you feel from your hearts, you want to offer your feeling thanksgiving to God. So this program, you're warmly welcome. You can offer your feeling thanksgivings of an amount. It will be received and paid the running cost for this program, so that hundreds of videos of basic engineering and science mathematics will be in air, just to transform your life from the present state where you are to the next state. So stay tuned. Remember to subscribe, remember to like, remember to share this content with others. Remember to visit the playlist of numerical methods. Remember to watch other previous videos. And also remember to be the first, remember to visit the online diploma POLYINSTIT of Tanzania in square bracket Olenjolai every day, in order to see and learn good news and actual yourself to love basic engineering mathematics, to love numerical method and series for the rest of your life. So may God bless you and keep you until we meet in the next session. This is your national teacher, your national engineer, your national technician, right? Your national teacher in technique or in competence-based, and international teacher, Olenjolai from Tanzania. I love you so much. See you in the next session. May God bless and keep you. Keep enjoying the beauty of numerical method and theories.